Hey guys, today we're going to be covering pages 17 and 18 in your notes packet, and our subject is graphing and evaluating piecewise functions. So if you look at page 17, this is the first problem on the page, and they want us to do two things: graph this set of piecewise functions and the evaluation where we find some values for it. Okay, so in order to graph, we have to treat each of these pieces as an individual function, and then we can work our way to the pieces that actually make up the whole. So, for example, if I started with this top piece right here, I can see that it says, hey, this is the absolute value of x plus 1, and it gives me this condition x is less than 0. So if I were to graph this function right here, you would see, hey, it's up 1 and it makes this V shape. It would be like kind of like doing this. And my graph might look something like this. But because I have this restriction right here, we're going to have to trim this graph down to fit that restriction. So what I'm going to do now is use this x is less than 0 to take away this portion right here that is ahead of that 0 mark, okay? And since it is not less than or equal to, just less than, I know that this circle is not filled in. That is an open circle that I have at that point, okay? And that is that first line that's been graphed for us. Okay, let's try that second bit, the one that is x squared, and it goes from 0 until 3. Okay, now let's make some notes. We're going to plug these numbers in to try and help us come up with what the shape of this graph is. And it's really convenient that we have two endpoints here. So I can plug in numbers from 0 to 3. So I'm going to start with 0. And if I plug 0 in, 0 squared gives me 0. So this is my x value and my y value. And let's just note, hey, this is less than or equal to 0. So this is going to be a filled in circle. And the 3, when I plug that 3 in, I'm going to get 3 squared is 9, and that one is a open circle. Now, it might be a little bit tricky. You might say, okay, well, I've got this filled in circle right here at 0, 0, and this open circle at 3, 9. But I don't know exactly how to connect those. Is it a straight line? Is it curved? Does it make a wave? What kind of shape does it make? Well, we can fill in an extra point, right, if we pick a number that's between 0 and 3, because x is between those two. So take your pick. What number is between 0 and 3? Probably some of you picked 1. Some of you may have picked 2. Let's just start by picking 1. So we can plug in 1 in here and get 1 squared is 1. And if we pick 2, we could say 2 squared is 4. So again, I'm making these x, y coordinates. What am I doing? I picked some x values that are between 0 and 3. So with these, I kind of have some extra information. And just graph enough so that you feel comfortable making this line, okay? And so you can see, hey, I connected my filled in circle with my open circle, no problem. Now, if we continue this, let's say, hey, we're going to do the third line now. Let's go ahead and do that. 2x plus 1, where x is greater than or equal to 3. So I'm going to do that off on this side. Let's plug in 3. So we've got x and y. We're just plugging in the numbers that we know. 3, and 3 times 2 is 6, plus 1 is 7. Okay? And should that be a filled in circle or a open circle? Well, that one is going to be filled in. Again, because this is equal to 3. All right? And how about another number, just so we have something that we can connect this with? We could pick any number that's greater than 3. Okay? So if you want to pick 4, 5, 6, 7, anything that's greater than 3, let's just do 4 for the sake of argument here. We've got 4 times 2 is 8, plus 1 is 9. And that is a part of my line now. Okay, so let's see what we've got. We've got 3, 7, and 4, 9. And so I can see, hey, look, this is trending upwards like this. And it is a straight line. Okay, you know this function is linear. All right. Now, let's go ahead and try the evaluating portion, okay? So evaluating, we have to make sure that we pick the right equation to plug this into, right? The right portion of our function. So my first question is, hey, f of 0, which category does that belong to? Is it this first one, the second one, or the third one? Well, if I look at the x values, my conditions, you'll see that, hey, 0 is not less than 0, so I can't use that first line. So instead, I'm going to use the second one right here, where x is between 0 and 3, which means I'm going to be using the blue marked function in there. So let's see, hey, what is 0 squared? Well, you would tell me that is just 0 again as your answer. Okay. How about f of 3? Well, f of 3, which category does it belong to? Try to pick which one of these filters should it fit in. Oh, it should fit in the third one, right? So if we looked at that, you'd say, hey, that's in category 3. That is my green equation. And we're going to do what? 2 times 3 plus 1. All right, so 6 plus 1 is 7. And if we look at the last one, 5, which one of these does 5 fit into? Same one again, right? We're back on that green one. So we're going to have 2 times 5 plus 1, and we should get this as 11, okay? So each of these are actually points that we could also find on this graph, okay? Now let's check out this domain and range. All right, so remember, your domain is going to be all the possible x values, and your range is all the possible y values, okay? So my domain, I'm going to start from left to right, and we're going to follow our graph. And we're going to see if there are any breaks in our graph. So I'm going to use this highlighter. I'm going to try and trace it. So I see this left arrow. So the left arrow means that I'm going to continue off until negative infinity. So let's start there. We're from negative infinity. And where am I going to? So I follow it, and then at 0, I see the first break. I see that my graph is jumping. But at least one of my circles is filled in, so I don't have to worry about that. I'm going to continue going to the right. And then I reach another point here at 3 where there's a break. But is one of those circles filled in? Yes, you can see that the green circle is filled in, so we can continue without stopping here, okay? And we're going to continue all the way up until that arrow. So again, I went from negative infinity until positive infinity, and we can see that there are no breaks in the domain, okay? So that means there are no stops on the x-axis at least. Okay, let's try to follow this along with our range as well. So range, we're going to read from bottom to top, okay? So let's find the lowest point on our graph first. And you should see that that is 0, okay? That's the point that is the lowest. It's down here. And from here, we're going to work our way upwards, and we're going to look for any breaks that happen where our graph is not connected. So far, I can see that the blue line is mirroring the red line, and I'm okay continuing upwards. Now, there's a point where we can switch from the blue to the green line here at 7. And I can see that there's a smooth connection all the way from 0 all the way up to infinity. I have no breaks in the y values, right? There's no gap in the middle of my graph, which means that I'm going to go from 0 up all the way until infinity, okay? Even though the red portion of my graph stops and the blue portion stops, the overall graph as a whole is not stopping. And so I can say that my range goes from 0 until infinity. Now, the best way to handle domain and range, guys, domain, go from left to right. and see if you can trace your graph without any gaps in it. For range, trace your graph from bottom until top. Make sure that you can trace it without any vertical gaps in there. And that will let you figure out the domain and range. Okay, let's do another example, okay? And this time, what I want to do is I'm going to start with these evaluate questions, and we're going to try and match them up with which equation I need to plug them in and then solve them. Because that's going to give us some extra points that we can even use to graph, okay? So let's start with f of 1, and let's see where that leads us. So my first question, which of the three categories does 1 belong in? Is it less than or equal to 1? Is it greater than 1 but less than 2? Or is it greater than or equal to 2? Hopefully you would say, hey, 1 is less than or equal to 1, and so it's going to belong in that first category. So we've got 2x plus 3, and we're going to plug in our 1 in there, and we should get 5. 2 times 1 plus 3 is 5. Okay? Which means I actually have a point here. It is 1 comma 5. I already had that x value, and they told me that 5 is my y value. So let's go ahead and mark that on our graph as well. 1, 5. Let's go to the next one, negative 2. So which category does negative 2 belong in? Is it less than or equal to 1, between 1 and 2, or greater than 2? You should actually discover, hey, this is also the same thing. And if I plug it in, negative 2, I should get that this is negative 1. Okay, so I've got another point here. Negative 2 comma negative 1. So let's see what we got. There's another point. And how about 2? Which one of these does 2 belong in? So is it less than or equal to 1, between 1 and 2, or greater than 2? You should get that it's greater than 2. Let's just do this one in blue. So we're going to just have our answer as being 2. Remember, if you ever see this where it's just a plain number, it doesn't matter what number you're on, it's just going to be 2. So over here I've got 2. Okay. All right, let's see if we can put together what this graph looks like. The first part is actually the easiest one, the part where x is less than or equal to 1. We've already got 2 points that go in there, and this is a straight line, so we're just going to connect these two together, and we should see what our graph looks like. So something like that, and my artwork is not perfect, and that would be the first part. So let's look at the second one, and we'll do this in green. So that part is going to start from 1 and go until 2. So we should plug in the two numbers. We'll use 1 and 2 as our values. Now, should those be filled in or open circles is the question. Those are going to be open circles because those are not equal to. All right, so let's plug in 1. So negative 1 plus 4 is 3. So I've got 1 comma 3. And we're going to have 2. So negative 2 plus 4 is 2. And these are both open circles. So here we go. 1, 3 is an open circle. And 2, 4 is also an open circle. Or sorry, 2, 2. And we can connect that. Now notice something cool happens here. This blue point that I had was actually filling in that green circle for me. And that's okay. We can have that circle get patched basically by this blue point. All right. And the third one is really easy to graph. Any number that's greater than 2 is automatically going to be 2. So it's just a nice little flat line right here. Okay. So that is the graph for this second bit, okay? If you're ever not sure, plug in some numbers that match this section, okay? So if you have x is less than or equal to 1, you can plug in any number less than 1 to make a point. if you have x's between 1 and 2, maybe you want to plug in 1.5 or 1.75 and get some new points so you can get a better picture of the shape. If x is greater than 2, you can plug in 3, 4, 5, 6, whatever you want, and it will give you a graph, okay? All right, remember you have to graph each one piece by piece. There's no crossing between them, okay? All right, let's go ahead and calculate the domain and range for this. So let's start with our domain. And we can see that, hey, my red line is going off to the left. My blue line is going off to the right. If I follow them in the middle, you can see there's always a filled in point. So my domain is going to be from negative infinity until positive infinity. Okay. If there was a break, let's say this red line didn't come all the way over here, it only came up to maybe -2, then my domain would absolutely be different, okay? We would have to say, hey, it actually has a cutoff point right here at -2. But in this case, our graph does go all the way up, and we had that green open circle as well. So we got to see that, hey, my graph was fully connected. Now let's look at this range. The range is kind of interesting on here. And again, we want to start from the low point to the high point, right? So I can see this downward arrow, and I see that means negative infinity. And I'm going up, and I see, okay, yeah, there's a flat line at 2, and I'm still going up. But then my red line cuts off here at 4. And I don't go any higher than that. So my ending point here is actually just 4. And remember, your range could be a little more complex than that too. You could have some breaks and stuff, and you can see some really interesting shapes emerge from that. All right, guys. On page 18, I want you guys to pause the video and try it for yourself before you look at the solution. Okay, so take a second right now. Go ahead, pause that video, and try it for yourself. Okay, so you can see my solution for problems on page 18. And you can see, hey, look, f of 5, that one fit into the x is greater than 2 basket. And we had over here f of -2. We said, hey, -2 is less than -1. We've got f of 0, which fit into this middle group between -1 up to equaling 0. And then we had this 1/2 that didn't fit in any of our brackets. And so we get that it's either undefined or does not exist or no solution, just because it's not actually in any of these different groups, okay? And you're gonna notice, hey, that means there's some section of my graph that actually doesn't exist. So if you look at your domain and we tried to follow that along here, you'd be able to see, hey, look, starting from the left, here's my domain, negative infinity up to -1, continuing on to 0. But from 0 up until that 2, I have a gap here, right? This section that I'm going to highlight in blue is a gap, and that's an issue, right? That break is going to be a hole in my domain, right? So that is a domain hole. And you can see that from my answer, between 0 and 2, there is no graph, and so there is no domain in here. So we've established that there's actually a break in the domain for this graph. Now, let's take a look at the range. The same thing, we're going to start from the lowest point possible. So I've got this low point down here at -1, and you can see it's not included because it's got that open circle, so it's a parenthesis. That goes up until 1, okay? And up at that 1, it's going to stop right there. And it's filled in, so we're going to put that brace. Now we're going to continue and look for the next piece. You can see that next number seems to be 4. It's got a filled in circle, so we're going to have a bracket there. And we'll continue up until infinity to get that infinity right there. Okay, so that is kind of finding the domain and range. This one had a pretty complex domain and range, so just something to keep in mind that, hey, your graph can have these kinds of breaks. It's important that we go from left to right for domain and from bottom to top for range and just try to get all of the different sections. So you can see there was a gap here, and that gap led to us having breaks in our domain and range, right? There's a horizontal gap and a vertical gap. Okay, guys, time for that last example. So go ahead one more time, pause that video and try to work out number 4. Now watch out, some of the graph part of this is tricky. So take a second, pause, and go ahead and try this problem for yourself. Okay, and if you look at the solution, you can see on the evaluate, I kind of marked them by color so you knew where to plug them in. Okay, and if you look at our graph, you can see each section graphed on there. And for our domain and range, you'll see, hey, look, the graph starts from the left, goes up to -2, continues on that blue line, picks up again on this pink line, and it keeps going until an arrow. There are no gaps, okay? There were no sections where I had to say, no, there's no filled in point or filled in circle. So this domain is from -infinity until +infinity. Now, my range is kind of interesting on the other hand, okay? So for my range, you can see, hey, down here, I have this small section. It goes from -6 until -5. And you can see that made its own little section of this range. Filled in giving me the bracket and open giving me the parentheses. Then I seem to pick up again from -1/2 right here. And that's that -1/2. And from there we've got going up towards 0 and from 0 to infinity, which leads me to this piece, okay? So that range is kind of tricky, especially seeing that, hey, this green line is going towards 0 and the red line is gonna pick up from that 0 to go to infinity, okay? But that is the domain and range and evaluating piecewise functions. The key thing to remember is, guys, when you evaluate, make sure that you're plugging stuff in the right section. When you graph, make sure you are using numbers that are in the criteria over here that match it, right? So if it says, hey, your numbers are supposed to be greater than -1, make sure that you're using numbers that are greater than -1. All right, and that's it for this one, guys. There's more problems on pages 19 and 20, the next 2 pages that have graphs and evaluating. Make sure that you practice and stay sharp on this stuff.